So hi, everyone. Welcome to the last seminar for this term. And we have Neelanjan Sircar, who's joining us from Hisar. I'm going to go ahead and say Delhi. He's joining us from Delhi. Neelanjan is an assistant professor at Ashoka University and a visiting fellow at the Center for Policy Research in Delhi. He's a political scientist with a PhD from Columbia University. And his research focuses on state-level elections in India, amongst other things, and also the decision-making behaviors of voters. To understand these complex dynamics, Neelanjan uses a variety of methods, and I'm just going to mention two of them because those were two that I understand, including social network analysis and ethnographic methods. I actually had the fortune of getting to know Neelanjan when he was doing a postdoc at the Center for the Advanced Study of India at the University of Pennsylvania, where I was studying at the time. So we've known each other for a while now, and our paths have crossed in Delhi and stuff as well. So I'm really happy to kind of be welcoming here, Neelanjan here to our seminar here, even though it's on Zoom as everything is this year, to discuss his talk titled Border-Free ELF Using Individualized Spatial Data to Measure Ethnic Segregation. So Neelanjan, welcome, and over to you.
All right. So thank you. I actually do know, as I was mentioning, I do actually know a number of you in the department. Ali, I know from my postdoc days. I know my brother since birth. I've taught Dennis at Columbia, so it's nice to sort of see a lot of familiar faces. I see other familiar faces of people who've joined. And also a big thank you to Ali and Eleanor for inviting me. I don't do methodology talks as much as I used to, and so it was nice to sort of get back into this material. So as I'm just starting my share, let me just tell you a little bit about how I came to this problem, and then sort of get into the talk. So this when I was originally contacted for a talk, I thought I was going to do some fun Facebook data kind of thing, and like so many things that are going on in the world today, that project is moving a lot slower than it needs to be, right? And so I pulled a plug on it as far as a talk goes in December, in early November, and I pulled something out of a file drawer, which was something I was excited about, but I just never sort of got around to getting to the next step. So I'm sort of excited to sort of see what all of you have to say about this. And I'll tell you a little bit about my sort of larger motivation for thinking about the set of problems that I'll be thinking about today. So there's no secret in terms of what I'm studying. When you look at the title of the talk, I'm interested in questions of religious diversity, religious segregation, and what are some intelligent ways of measuring it. And so much of what we do when we think about these measures is that we work at scale, right? We're working at the level of an urban agglomeration. We're working at perhaps the level of a country at times. And we're trying to understand how to sort of aggregate individual discrepancies in terms of where people live to make claims about segregation, to make claims about diversity. So I wanted to sort of start with this slide because this is actually where I live in Delhi. So for those of you that know Delhi, you can probably recognize what neighborhood this is. This is Nizamuddin. This is Humayun's tomb. This is where the second Mughal emperor is buried. And now it may seem like a beautiful tourist site, but actually at Indian independence, it was a refugee camp. And a lot of this area actually is refugee settlement, people who were refugees from Pakistan at partition, at independence. And so I want to give you a sense of what the spatial geography here looks like, to tell you just sort of the kinds of problems that we are engaged in when we think about segregation and diversity. So this is the neighborhood that I live in. This is Nizamuddin East. Nizamuddin East is an upper middle class neighborhood. It started out as a refugee colony, but it is now broadly, largely a Hindu upper middle class neighborhood. It does have a significant Sikh and Muslim population, but less than it used to at some point. On this side of the road, and this is a major road, This actually is the Grand Trunk Road for those of you that don't know. This is a road that connects Afghanistan to Dhaka, and of course now it's been broken up, but it does go through the middle of Delhi. On this side of the road is Nizamuddin West. Here is another neighborhood which looks a lot like Nizamuddin East. It's an upper middle class neighborhood, somewhat mixed. And this is a more dense settlement that is around a Sufi shrine, the Nizamuddin Dargah, and that is a largely Muslim neighborhood. On this side, literally across the train tracks, this is a major train station, is another very dense settlement with a large sort of Hindu-Muslim mixed population. Now, I wanted to sort of bring out this kind of topography because this is broadly what you see in many of the cities in the global south. Now, we have to sort of look at a city like this and try to make claims about segregation, to make claims about diversity. And one of the things that's quite noticeable here is that while we like to have very neat boundaries when we describe where people live in this neighborhood versus that neighborhood, and you do see some big boundaries, in fact, it's quite a bit more mixed, right? An upper class neighborhood is mixing into a poorer Muslim neighborhood. People are actually crossing the street all the time. I do for sure. And while there are sort of noticeable barriers, there is also some level of penetration. Right? So the reason why I bring this up is to sort of notice two things that are happening on this map. First, insofar as we can think of a spatial barrier, there's actually some physical distance, right? So we often mentally think about barriers as being, okay, here's a neighborhood, there's a wall, and there's another neighborhood. But especially in the global south, if that's all a barrier were, then people would be going back and forth. So often we're talking about much, much larger barriers. I'm reminded of my time at Columbia, where the boundary between Columbia and Spanish Harlem was like a 500-meter drop, Morningside Hyde Park, right? It was physically separated, right? And this is the kind of large distance separation that you think about when you're thinking about spatial segregation. The second thing that I want to sort of point out here is that if we were to just simply take the neighborhoods as a whole, then we would be missing certain clusters of people who live with sort of very, very different identities, right? So I can have boundaries that are too large, I can have boundaries that are too small, and I can perhaps take boundaries too seriously, right? These are all things that sort of come out when you look at it. And so what I'm going to do today is sort of try to think a little bit about how our measures of diversity and segregation are affected when we start sort of playing with what the boundary is, when we remove the boundary and use spatial distance as a way of sort of characterizing how segregated or how diverse a locality is. Okay. So I don't think I need to mention too much of this to this group. Why should we measure diversity and segregation? Spatial organization is, of course, a major study in and of itself. We also understand that in a larger political economy setting, segregation, spatial diversity is known to have predictive power for a number of outcomes that we're interested in, public goods provision, so on and so forth. I'll show you something along those lines in a little bit. The focus of this talk is to think a little bit more about how we're going to measure diversity and segregation. Broadly thinking in terms of what does variation in social heterogeneity look like in spatial terms. So I'm going to be bringing in spatial data here. And I'm going to be critiquing the usual indices that we use. I'm certainly not the first person to critique them. But my angle of critique will be towards sort of introducing more spatial information into the way that we characterize segregation, dissimilarity, ethno-linguistic fractionalization, so on and so forth. Now, I've listed two sets of measures that you may or may not have heard of based on your discipline. I'm going to go over them briefly, so don't worry if you haven't. One is the index of dissimilarity, D. Another is ethno-linguistic fractionalization. I'm going to sort of lean towards ethno-linguistic fractionalization. I'm going to be studying religious diversity and segregation in Delhi, and we're often talking about more than two religions. So we often want some a measure that we can interpret that is useful along those lines. By the way, I'll be throwing a couple of measures here and there. So any questions any of you have, please break in as. Okay, so here's the sort of first sort of intellectual imposition. When we are constructing our measures and we're aggregating across space, and I'm going to show this in some detail, we have two dimensions of fixity. The first dimension of fixity is that we fix the groups that we are defining for segregation or for diversity, right? So when we talk about, for instance, racial diversity in the US, any measure that you can think of has enumerated the races ahead of time, right? And then some measure of diversity is being calculated. Now, a natural question and a topic that I've worked on is that, well, can't you endogenously define groups from network data, from other kinds of spatial data? You can, but typically the way, if you look at the algorithms that are being used to define groups, they're maximizing some statistic, which looks a lot like segregation, right? So it's sort of cheating to say, I've picked groups that maximize segregation, and hey, look, I have a lot of segregation, right? That's not the most useful thing when you're studying groups. And so we typically will redefine groups only because endogenously defined groups are often sort of impinging upon the thing that we are studying. For those of you that are sort of interested in data mining questions, the way that I think about the endogenously defined group problem is the same thing as Fisher's discriminant problem, right? It's basically one where you're trying to minimize the variation within the group and maximize the variation across groups. And essentially, the algorithms are doing some version of a discriminant problem, but in network space. Now, the second thing, which I do think we can relax, the second dimension of fixity, where I think we can relax some information, is that of borders. So in almost every index that we calculate, in almost every study that we have, we say, okay, these are the borders of the neighborhood. These are the borders of the geography. And if I want to understand heterogeneity or homogeneity of the social ethnic composition of these geographies, I will just simply look at the variation in the composition of these different geographies and make a claim about segregation, diversity, so on and so forth. Now you can already see where I'm going to go with this based on my first slide, that the need to define explicit borders for most of our measures is a huge challenge. And what I'm going to show you is that many of the data that we have are actually quite sensitive to the way that you define the border, right? Insofar as, and we're all schooled in literatures in which the neighborhood is a very important unit of study, but insofar as the neighborhood in and of itself is a natural set of boundaries, we require a certain set of sort of social sorting assumptions that maybe don't hold as much in the global south, maybe don't hold much anywhere. And so just by looking at the boundaries of a neighborhood, it can be very, very tricky to make characterizations about segregation, right? For some of the reasons I talked about. The other reason is the world that I inhabit. I don't really trust a lot of the data. At different levels of aggregation, data are spotty. There's a lot of politics in what data gets released. And so it would be nice to be able to use our primary sources, our survey sources, to be able to make these kinds of calculations. So what I'm going to argue here is that when we have GPS data, when we have spatial data on where households actually live, we can start relaxing assumptions about borders, and we can start making meaningful claims about segregation and about religious diversity in the case of what I'm talking about. Okay, so as I mentioned, we'll just do a couple of preliminaries here. Index of dissimilarity, in case you haven't seen before. there are a fixed set of geographies. Let's call them neighborhoods. Okay. I have two groups. Let's call them the A's and the B's, right? All it does is it takes the absolute difference of the proportion of the A's and the proportion of the B's in each geography and adds them up. Right? So in other words, if I'm in a particular neighborhood and 10% of the A's live in that neighborhood and 5% of the B's live in that neighborhood, then I will say that there's been some kind of social sorting that makes the B's less likely to live in that neighborhood than the A's. Right? And then I use some kind of absolute difference measure. There are known problems here. This only works for two groups. People often extend this to an entropy measure. I'm not going to talk about an entropy measure today because I'm going to go to the ethno-linguistic fractionalization. One of the cardinal difficulties of index of dissimilarity is that it only works with two groups. For my purposes, the bigger challenge, of course, is that you have to have defined your N geographies ahead of time, right? I'm going to talk about why that's going to cause some problems for us as we go forward. So what I'm going to do is, because I'm dealing with multiple groups, and I'm, in terms of religious fractionalization, which is the easier case in South Asia, because once I start talking about caste and so on, so it can break in many, many ways. I'm still talking about, in the case of Delhi, 4 defined-ish groups: Hindu, Muslim, Sikh, and other, because there are plenty of people who don't identify with any religion. These are a measure like this is not going to be sufficient for understanding religious segregation and diversity. So a standard set of tools that are used to understand diversity across different ethnic groups, linguistic groups, any kind of groups really, are based off of Hirschman-Herfindahl indices. And the standard logic, I'm going to give you a visual interpretation in a second. But the measure is super simple, right? It is, you take the share of each group in the population, you take the sum of their shares squared, you subtract that sum from 1, and you have a measure of ethno-linguistic fractionalization. And the interpretation is that it is the probability that 2 randomly selected people are not from the same group. Okay? I'm going to show you that in a second and why that happens. One annoying thing, it's going to show up a bit later, is that we like to think that this index goes from 0 to 1, but it is actually dependent upon the number of groups that you have. So if you have m groups, the maximum is 1 minus 1 over m, or m minus 1 over m. Okay. So here's a simple setup to sort of think about what's happening visually. Here's some person, self, me, and here's everyone else in the population. I'm thinking of 3 groups: share 1, share 2, share 3. The sum of the shares, this is a unit square, the sum of the shares add to 1. Okay. Now, this could be about any person chosen at random. So the person who's chosen at random is from one of these groups that is proportional to the probability of their share in the population. And the probability that somebody who is from group 1, share 1, meets someone else from group 1 is going to exactly be this square. Okay? Probability that somebody from group 2 meets someone from group 2 is exactly that square, and the probability that somebody from group 3 meets someone from group 3 is exactly this square. Okay? And therefore, the probability that somebody meets someone from outside of their own group is this red area. Okay? So you can just sort of play with this a little bit, and you can sort of see that as the shares become equal, I'm going to maximize the probability that I meet somebody from outside the group. As one group gets very large, the probability I'm going to meet someone from outside the group is going to get much smaller. Okay, so this is how ELF works. So how might we use ethno-linguistic fractionalization to think a little bit about segregation? So what I've done here is, sorry, hold on one second. Apologize for that. Can everybody hear me? Are you able to hear me?
Yes.
Okay, great. Sorry about that. Okay, so let's sort of, let me just take a step back here. Okay, so I have ethno-linguistic fractionalizations, right? Now, one way to sort of think about how I can start measuring segregation from ELF is that it is a natural measure of diversity of a space. I can again take my n geographies and I can simply sort them from least diverse to most diverse, right? So I've called this quantile because it's on a unit scale and not on a scale from 0 to 100, right? And I've just simply done this from lowest to highest. This isn't exactly like a Lorenz curve because Lorenz curve actually sums the values, right? This is just the individual values. This is just sorting them. And you can see that because we're on a unit scale, the area underneath the curve is the average of the ethno-linguistic fractionalization values of the geographies. Okay. And insofar as I want to calculate any kind of deviance from a common value, I can just take the mean absolute error, right? So I have just simply taken this, I lined up my separate ethno-linguistic fractionalization values from smallest to largest. I take the average and the shaded area is just the mean absolute deviation, mean absolute error. Okay. For those of you, as I said, who have a background in machine learning and data mining, you will know exactly what this is. And part of the reason why I like this is that it shows us that the average is only one thing that you can do. You can imagine having a more sophisticated function, and you can still define the kinds of measures that I'll be talking about today. So a natural measure of segregation, which is just simply the variance in the some measure of how much diversity, religious, ethnic, group-wise diversity varies across various geographies. Mean absolute error is a natural measure to use. Now I've called this unstandardized because this area could in principle be anything. One way of just quickly standardizing it is to look at the worst case scenario. The worst case scenario is that there's some maximum value of the ELF that happens in as many geographies as possible. And then the rest of the geographies, you have 0 ELF. Right? So that would be the worst possible case scenario. That would be the greatest segregation. And therefore, any of these mean absolute error areas will be less than this. And we simply need to sort of calculate the mean absolute error and compare it to the worst case scenario to get a number between 0 and 1. So this is an equation that looks scary. I'll tell you, it's not as scary as it should be. It's just sort of, it's annoying. It's coming partially because of that m-1 over m business. The maximum of the ethno-linguistic fractionalization is not 1 when you have m groups. This is the mean absolute error. And this is the worst case scenario once we divide by m-1. You can see that as the number of groups gets very, very large, then we're going to converge to 2 times p over 1 minus p at the bottom, which is a much easier function to use. Okay. So this is going to be the sort of standard measure of segregation that I'm going to use throughout the rest of this talk because it's sort of natural and it has a very natural interpretation. But obviously other ways of measuring segregation are possible. I do want to encourage though that unlike some of the old measures that we have, something that is based in the way that we think about classification, prediction error is probably a good way to go just because it's highly flexible for other tools that we're using. All right, so I want to just sort of start with a few considerations and I'm going to try to finish up in about 10 minutes or so. And sort of open it for questions. So all of this is great. We've now come up with a way of thinking about segregation. We can do it in multiple groups, but we still have that pesky problem of having n geographies, right? So can we do a little better than uh, that by sort of thinking hard about what borders, or if we can remove borders? Okay, so first obvious thing is that borders matter, right? So here's a checkerboard. There are two groups, the red group and the white group. And I have 4 geographies. Each of these geographies look fairly mixed, and they're equal in their mixture. Had I made the geographies this, then, certain parts of the checkerboard are only white and certain parts of the checkerboard are only red. So this looks like a very highly segregated scenario. Now you can see already one of the big problems we have is when we just simply enumerate geographies, but we don't talk about where the geographies are. There is no differentiation between any of the measures that I've just mentioned between this case and this case. Intuitively, we like to think that this is probably a worse case of segregation than this, but that requires some understanding of the relative spatial relationship between geographical units, right? Which is not being used in any of these measures that I have outlined for you, right? So how can we do that? So I've sort of proposed, and you'll see its properties in a second, a simple border-free measure. Now, essentially, what all I'm doing is I'm weighting the probability that 2 people meet each other from the same group. I'm weighting it by the inverse of the distance between them squared, right? So now if I happen to know exactly where on a map 2 households live, then I can calculate the distance between them. And I can put an appropriate probability or distance between them. This sort of summing of the weights being equal to 1 is just a scaling factor. The more important thing is that the probability that you interact with somebody else is inversely related to the distance squared. One way of sort of thinking about this is that the probability that you go to somebody to go meet them is inverse proportional to the distance, and same thing with them. So when you multiply them, you're getting something that is inversely proportional to distance squared. This is actually, it may seem like I'm pulling this out of thin air. It's not unusual to use inverse distance squared measures in many spatial applications. So it's something that you will see quite a lot when you look at spatial data. Now, what I want to do is I want to use just this very simple idea to recalculate our ELF measures and see what it does to some of the problems that we were facing with borders. So what I'm going to do is I'm going to say simply that the share of a group now is going to be the sum of the weights of the people within that group. Now, so for a person I am simply going to calculate the distance between that person and every other person in the population. And I'm going to sum the weights of each, I'm going to sum the weights separately for people in each group. That's going to give me a share for each group. So just to sort of put my data, I have Hindus, Muslims, Sikhs, others, right? So the weights will correspond to each of those 4. The sum of, let's say, the weights of the Hindus will be 0.5. The sum of the weights of the Muslims and the sum of the weights of the other group will be 0.15, right? And I can treat those as shares and calculate my usual ELF measure. And what's nice about this is now this is an ethno-linguistic fractionalization measure that is unique to the individual, right? It's no longer something that is bounded by the geography. So each individual is actually getting a different measure for the ethno-linguistic fractionalization. Okay, this is just talking a little bit about how one might calculate it. If we have a multiplication trick that will allow you to do all of this. Basically, there's a way of calculating a matrix so that the rows of the SI values, these share values. So once I have the rows of the matrix being exactly the shares I need to put in ethnolinguistic fractionalization, it's just a hop skip. Okay, so this is I don't like talking, data set that I work on it, and these ideas. So I'm looking at the national capital region, which is the area around Delhi. It in 2011 was an urban population of approximately 30 million and a total population of about 50 million. And the population is growing about 20% per decade. Urban. The survey is only sampling the 30 million area, the urban areas of the region. And I'm going to be looking at how these various measures of ELF apply to a religious diversity and religious segregation measure for Hindus, Muslims, Sikhs, others. This is a representative sample across, but we're only able to have usable geographic data for about 4,400 households. We can talk about all of these issues in a second. Now, there are a couple of things that I want to talk about before I go into the final measures here. It is important for us to understand that when we are using primary data, that it is likely that our data will be clustered in some way. And those clusters are meaningful for the way that sampling is done, but they're also meaningful for the way that calculations are sort of manifesting. And it will require some thinking about what is the optimal density of clusters and polling booths when you come up with any of these measures. In my case, I got a bit lucky. Polling booths are standardized to the population. They're on average 1,000 voters. So the location, the spatial location of the polling booths and the clusters sort of track the population density of the region quite well. So I don't have to worry about these issues as much. So what I'm going to do is I'm going to take the border-free measure. I'm going to compare it to data on polling booths, clusters, spatial buffers, and just try to sort of intuit a little bit about what's happening. Okay, so first things first. So I told you that the data are sampled over about 100 clusters and about 500 polling booths. There are on average 5 polling booths in a cluster. And I have simply, over the exact same data set, calculated the border-free ethno-linguistic fractionalization, the polling booth measure, and the cluster measure. And you can immediately see right here the thing that we were very worried about when we were defining borders. When the border gets too small, I have a huge number of places that have 0 ELF. 50% of the polling booths are completely homogeneous. When I take a larger area across 5 polling booths, then a much smaller proportion of them are completely homogeneous. Now, how should you actually choose that boundary? One of the nice things about what the border-free measure is doing is that in these areas where we're at sort of extremely low levels, it's giving us a reasonable sort of smooth measure of, sort of what diversity should look like, right? These are exactly those sorted graphs I've told you before, right? So from lowest to highest, lowest ethno-linguistic fractionalization to highest ethno-linguistic fractionalization. So you can see that especially when it comes to this sort of problem, it's likely that not having to think hard about your borders is going to help you a lot. Now, just to be very clear here, the clusters on the borders do actually hew to natural boundaries in Delhi. So these aren't just like random grids I've drawn. These are actually, they have meaning in terms of neighborhood. So it tells you just sort of how finicky any kind of ethno-linguistic fractionalization or any kind of diversity measure will be to the borders that you have. Just for posterity, the segregation measure for clusters is 0.52, and for polling booths is 0.65. For the border-free measure, 0.6, so it's kind of splitting the difference. The average ELFs are actually quite similar across the three. For the cluster, it's 0.15, polling booth is 0.13, and for the border-free measure, 0.14. Now, I was actually a bit surprised by this result, and but I'll sort of tell you for a second. So a natural critique that I had of my own work and others had would just say, okay, look, geographers have solved this problem. What geographers do is they look at GPS coordinates, they draw a buffer, which is to say they draw a circle around each household that can be of a particular size, 0.15 kilometers, 0.3 kilometers, 1.5 kilometers, right? Whatever you want, 2 kilometers, 10 kilometers, right? And they calculate the measures within those boundaries. You can see that this thing, all it effectively does is that when the buffers are small, you have the same issue like the polling booths. You have a lot of polling booths that are a lot of buffers that are homogeneous. But once you start having positive diversity in your buffer, right, ELF greater than 0, then you start sort of seeing a very explicit linear smoothing of your measure, right, which is not optimal, right, because we do intuitively think that any kind of inequality is going to have some kind of convexity like this. And these shapes actually look quite weird, right? So just to sort of what's essentially happening is the buffers are actually, all they do is they spatially smooth anything, right? They're not actually accounting for the relative distance between individuals when you are calculating any kind of diversity, which is to say that it is still the case that the boundary is doing a lot. People within the boundary are being weighted equally. People outside the boundary are being given 0 weight, even in a buffer calculation. What is different in the border-free calculation is that every single person in the population is being given a weight, which is what is sort of creating this kind of shape and this kind of smooth metric. Again, just for posterity, when the buffer was 0.15 kilometers, segregation was 0.6. When the buffer was 0.3 kilometers, it was 0.48. When it was 1.5 kilometers, 0.37. So buffers were segregation. And the average ELFs are also quite a bit higher. Okay. So here's a spatial spline of this data. So what I've done is I've taken the ELF measures, I have them at the individual level. I've run a spatial spline to smooth the data. There's this funny gray spot here, which means that the ELF is off the charts. I think this is actually Sangam Vihar for people who know the area around Delhi a lot. It is one of the largest slums in Delhi and extremely diverse. So it just sort of stands out as being super diverse. But intuitively, what we are seeing here is something that is natural for the way that we think people sort of visualize what's happening in Delhi. So this area right here that you're seeing, which is quite diverse, is Northeast Delhi. This is the site of a major riot that took place earlier this year. The largest riot in the Muslim population. Right? And that shows up very clearly in this data. And you can see again that had we just simply taken separate geography, it would have looked noisy, it would have been hard to see. Once you start sort of taking individualized, you can sort of parts of Faridabad, a few parts of the ring, you are actually seeing places that are less diverse, that are actually broadly dominated by Hindu population. This is broadly consistent with what we think about ethnic fractionalization and segregation. Okay, so just very quickly, I want to talk about how you might use this in any kind of analytic sense, not just putting this on maps. Um, so it's very common to use ethno-linguistic fractionalization as a measure, as a predictive measure, as a predictor in a regression, in any kind of correlation exercise. And Abhijit Banerjee, Lakshmi Iyer, Roni Somnathan have written that one of the most powerful hypotheses in political economy, social divisions undermine economic progress. And the way it's typically shown is you put ELF on the right-hand side of a regression, you put something nice that would be nice to have on the left-hand side of the regression, you show that they're negatively correlated. Right? Two mechanisms of positivism in the literature. In high capacity states, you have dominant groups, white flight, basically, divesting from important programs, leading to less provision of public goods. In low capacity states, you require some coordination between the population. When there is ethnic division, religious division, social division, it is harder to get that kind of coordination. It's not a talk about the quality of this hypothesis, but just to show you that it can. Less of an understanding of how models of state citizen intermediaries are affected. So what I wanted to do was talk about some sort of special data from the survey that I'm talking about. So this survey is actually, I have early next year, there'll be a book coming out from Cambridge University Press, which is essentially looking at all of the data that's come out of this survey. It was a large, we asked was about intermediation, so the relation between border-free ELF and local intermediation. So we asked each of our respondents, is there an intermediary that is available for them to address their grievances? 74% said yes. There were further questions on whether issues were solved, what kind of grievances were raised, so on and so forth. I've actually written a chapter. I can tell you more about this data if you want. It's not the point of this talk. What I want to do is simply look at this binary outcome measure and look at its correlation with border-free ELF. Now, the hypothesis is that where you have more social diversity, where you have greater ethnic fractionalization, religious fractionalization, it is going to be harder to have committed local leaders or netas in South Asian speak, because essentially there's too much diversity, right? And netas are often delimited by the social group that they represent, okay? So one thing that is nice in the regression is that we're getting sample size benefits. The ELF is not at the level of a geography, it's at the level of the individual. But you have to be careful. The ELF is explicitly using data from and the spatial distance across the population. So you shouldn't be treating these as independent observations. So I can talk about a few different bootstrap procedures like check. Broadly, they all kind of do the same thing. The standard bootstrap procedure here is to randomly sample exactly the number, recalculate your statistics. Okay. You can see that there is indeed a strong negative relationship between ethno-linguistic fractionalization at the individual level and the probability of having a leader to go to, which is consistent with this hypothesis. I think part of the reason why it's important to sort of think about individualized measures of fractionalization, that again, a standard model of neighborhood or a geography and a standardized notion of public goods, different people have access to water, different people have access to different quality of roads, all within the same neighborhood, right? You can have small enclaves that are from one group, from another group, right? So being able to sort of access a more individualized measure of fractionalization that doesn't hew to boundaries that may or may not be impactful for the outcomes that you're interested in can be quite helpful in this context. Okay, finishing up. There are certain promising elements of calculating ELF from distance decay type functions. I used inverse distance squared. We can think of other things. What is nice about it is that it sort of avoids some of the ugliness that we see when we're choosing our borders, and some of the jumpiness of our measures of segregation and ethnic diversity. Their distance decay function, inverse distance squared is quite common in people who work with spatial data. So I think that's, a reasonably nice way to go. I think for me, the big takeaway here is that, so many of the measures that we use at scale, and I say this from the book that I've just edited as well, a major part of the book was learning how to use localized spatial data to make claims at scale, right? Once you have geocoded data, once you have GPS coordinates, distances, so on and so forth, there's a lot that you're able to do, right? There's a lot you're able to do that our traditional measures haven't been able to do. Now, I've only used spatial distance here. You can think about social distances more broadly, accounting for barriers, accounting for I've recently used transportation algorithms as a basis for sampling because I didn't trust the spatial distance, right? There are a lot of things you can do, right? But broadly, you can use some distance once you have geocodes to be able to form meaningful measures of segregation. Is to get some math right, which is to say that right now I just gave you a data set, and I'd like to know something about the sensitivity sort of distribution. Thank you, and any questions that any of you might have.
Thanks so much, Neelanjan. The way we usually do this is that people should feel free to ask their questions. You can raise your hand, or you can type your question into the chat box, and then I might call on you, or I might just read out your question, whatever you prefer. So just feel free to kind of, dive into the questions. Thanks so much, Neelanjan. Okay, perfect. So we have a question here. I'm just going to unmute you.
Let me shut my video for a second because I think my connection is slowing.
Okay.
You guys hear me clearly?
You're breaking up a little bit.
Yes. Right. Okay. Yeah, it's a bit of a. It's clearing up again for me again now. Are you able to hear me?
Yes. Yeah.
Okay. Great.
So I think the question was from, I don't know how to pronounce. Yes.
Yeah. Yeah. No. So as a political scientist, I'm very familiar with ELF because it's used to measure party system fractionalization. And fun fact is that the reciprocal of it is the effective number of parties. And so, in terms of religious and ethnic fractionalization, this would be the reciprocal of ELF would be the effective number of religious or ethnic groups. So if there was one very large ethnic groups and lots of little ones, you'd have the reciprocal would give you a very small number of effective number of groups and so on. It's very clever, I think, to weight that by distance and get away from the problem of boundaries. But I still think you just touched on it very much at the end of the talk, that the issue of social distancing is important. I can see in terms of distributing public goods and things like that, it might be important to have geographical distance, but in terms of how people feel about segregation and what it's like, it seems to me that it would be interesting to think about whether, it makes a difference to me if somebody from the same group is 100 yards away, half a mile away, a mile away, 2 miles away. I might not care at all if a person is only half a mile away, but I might care a lot if a person is 100 yards away. So I wonder if you get a very different measure if you set different boundaries on how people perceive the social distance.
I think I've lost
Nilanjan, you came back a little bit.
Maybe you could write out your question in the chat. Maybe we can turn to that. So if Neelanjan's connection is a little bit more spotty, then we can at least have that to refer to when it comes back, hopefully.
Can you hear me now?
Oh yeah, now we got you.
Yeah. I think I figured out what's going on here. So I did hear McLaver's question. So I can go ahead and answer that if I'm not I'm stepping on anyone's toes. So look, I completely agree, right? I mean, I think thinking about social distance, so the larger study actually also asked about whether people are interacting with their neighbors, the extent to which they're interacting with their neighbors, and of course, there's huge social sorting by religion and not by caste, right? We're actually finding in Delhi cross-caste interactions with food and so on and so forth was surprisingly high given the history of South Asia. Not so much with religion. Muslims were eating in Muslims' homes, Hindus were eating at Hindus' homes, and not going to each other's homes, even when they lived side by side. So there certainly is an element of social distance that is beyond spatial distance. So one answer is, look, this is a measure of spatial distance, take it or leave it. I don't think that's a satisfying answer. I think the other answer is that are there a set of variables that you can put to test? So in other words, imagine that I asked in a more systematic way the questions about interaction. Is there a way of joining that with spatial distance to create a better social distance? We had a failed version of that in this survey, so that's why that's not included in here. We asked people about their own neighborhoods and how diverse they were, and most people just said, I have no idea what you're asking me, and didn't answer the question. So I see there's a question on the window. The question is, what would happen if you were applying it on the countryside? So what's going to happen is, as long as we're all on the same sort of density scale, right? So in other words, let's take a very dense place and a very non-dense place. The standardization is going to take care of some of that, right? Where problems will emerge is when you are trying to make similar claims across places that are very dense and not as dense, and whether you would, and perhaps that would say something about the relative, it would be unfair to characterize something about the relative levels of segregation in that context, right? I would still say though that, like, first of all, I mean, in the South Asian context, we're less worried about that. Everybody's very close to each other, but also, I would say that even if we are in the hinterland, the fact that people are more spatially spread still probably says something about the probability that they can interact with each other. I mean, we do intuitively think that people in slums are seeing each other a lot more than people in very large spread out villages.
I think there is a question from Yoni, and then I've got one too, Alia.
That's good.
Yes, thank you very much. Very nice talk on a satisfyingly technical topic for someone like me. Just a preliminary question first, whether I've understood this correctly. This is about the type of data that this uses and where it's all calculated. The definition of the quantities involved pairwise distances between each pair of individuals in a population, those delta Dijs. Presumably for all possible pairs in a big population, which you won't know all of them. But then these are estimated from a survey for the people who are in the survey. Is that correct?
That's exactly correct, right? So I sort of mentioned very quickly that you might be worried if the spatial distribution of your sample is dramatically different than what the spatial distribution of the population might be. That I think, thankfully, in this particular case, I'm less worried about, but that's a genuine concern. But yes, this is sampled data in which we have geocoded households. In which, but you can imagine that if you had a 1% sample that was geocoded, then that would be a nice way of having to deal with this if you had sort of census data that.
Yeah. So on that level, in terms of what data are required from the survey is basically the group of a respondent and where they are, the location. So any survey that provides the material. But my question then is to follow up about the sampling properties of this, which there are two stages to it. Even for any particular person who is in the sample, we have an only because we don't have everyone else, even for that person, we have an estimate of that person's average distance from the rest of the population, so to speak, a sample of all the others, so to speak. And then there's this fact that each area is only represented by the sample of those people who are, or each sort of location, or roughly not specific bordered neighborhood, but any place generally is represented by those who happen to be in the sample from thereabouts in the space. So are there any sampling considerations or concerns on both of those levels, given that this almost always will come from a sample from a complex sampling design, indeed clustered sample, which is almost by definition connected to the issues considered here? So do, for example, the estimates need to be weighted in appropriate ways and so on? Are there any concerns of that nature?
So, it's an interesting, I mean, I think that's sort of what I sort of was hinting at with next steps. My intuition, just the stats intuition here, is that once we have introduced weighted persons in the calculation of shares of whether you're the share of Muslim, share of Hindu, there's nothing stopping you from being more sophisticated in what those weights are. Right now, those weights are just simply being calculated from spatial distance, right? But you can imagine that I can just simply weight certain people in the population more heavily based on, where, so if I've oversampled a region and undersampled another place, right? If I happen to know sampling probabilities, right? These are all weights that you should, in principle, be able to apply, right? So I think part of what I was trying to get across in this talk is that I've structured this in one way, but by appealing to a weight matrix to apply to make the calculations, and B, some version of a mean absolute error, there are a number of ways of using essentially this standard technique to be able to sort of get your way out of a number of these kinds of problems.
Thank you. And I get, just to follow up, that's kind of thing I meant in the sense that I meant the weights in survey sampling sense, the weights that reflect the sampling probability, standard design weights, which would be present for any well-designed survey, which I think then should be used just like they are used for any other survey estimand, because despite the more elaborate nature of what is being calculated here, they are nevertheless survey parameters that are estimated from that survey. So whatever else is done, it seems that the sort of standard survey weighting for simply the unequal sampling probabilities should come into it in an appropriate way.
Yeah, absolutely. I think so. I mean, in this particular case, I said I was able to thankfully not have to deal with that. I did a lot of work to show that the sampling weights were not particularly needed in this particular case, but that's a function of how the sample is drawn. And it's rare that you get that kind of outcome in most of these designs. There are post-stratification weights, right? But sampling at the level of the initial sampling, it wasn't necessary. But no, but I think your intuition is exactly right, which is there's absolutely no reason why you shouldn't be able to introduce sampling weights into your weight matrix and just calculate through as you would otherwise.
Thank you.
Okay, so I see a couple of questions there. Rimjim, who actually worked with me at CPR, so I was asking about the distance decay function. all of the decay functions, because of the individual nature of this, are going to create some kind of smoothing. So if you use a more sort of aggressive, let's say I made it inverse proportional to d to the fifth, then essentially you are you're weighting people further away less and less and less. So you're making presumably there's going to be less diversity in those measures on average. In terms of the staggering and the sort of jumps, that is due to exactly the border problem. So my instinct would be that, you know, sort of naturally, if we want to sort of think about the world that people live in, those kinds of staggers and jumps are very hard to justify because they're completely determined by where we've placed the borders. And that's not optimal, right? Perhaps there's a way of thinking about how to smooth across many borders or average across borders in a way that might be meaningful, but we typically don't know that, right? So one of the advantages of being able to use spatial distance is you can sort of get your way out of that problem. Mick Laver has a question. Highly segregated areas, especially poor ones, can have high population densities. How might we think about this? So, you know, what's going to happen here? So, you know, I have actually thought about this, and you know, something interesting happens, right? Which is the following. And I said, you know, some more investigation densities needs to happen. Now, if I'm in a very dense area that is still segregated, it is still the case that I am putting a disproportionate amount of weight on people from one group that are close to me. So, right, so it is still the case that when I calculate my shares, yes, it is true that there is more unstandardized weight on people from another group who are a little further away from me in my slum, but there's also more unstandardized weight on people who are from my group in my slum. And so when you standardize it out, right, because what we're essentially doing is that we're making sure the weights sum to one, a lot of those issues do, you know, work themselves out. The way in which you're going to start getting very different weights is when the distances vary in some more complicated way, right? In which case the squared decay function is going to hurt people who are further away as opposed to people who are closer away.
But what I just to cut in there, what I was thinking is if different ethnic groups have very different densities, because they have different levels of wealth, and you're aggregating across an area which includes many ethnic groups, some of which have different densities, is that not a problem for you?
So at the individual, so you see, because we're aggregating at the level of the individual, it's tricky, right? So it is still the case that in a less dense area, the closest people to you are still from your group, right? So I was surprised by this when I was throwing the numbers out, because you saw that when I put the curves on, they actually kind of match the spatial geographies, they smooth them in a particular way. What's essentially happening is that process of standardizing the weights is in some ways also standardizing the space, right? Because you're standardizing by, if I take, for instance, the ratio of the weight of the second closest person to me and the third closest person to me, right? That it's not clearly just a function of how close both of them are. It's a function of how far they are from me in terms of ratios, right? So that's why some of this is canceling out even when you're in less dense areas and more dense areas, because you're standardizing to the distance from the individual, right? And not in the population as a whole. But I was a bit surprised. I mean, the question you ask is exactly where I thought this was going to go off, right? And it probably does, right? If you, as I said, when we investigate, I'm sure we can make this break if I write population densities in some way, right? But I'm surprised at the extent to which it doesn't break. Because actually, even the geographies I've given you have quite different density patterns.
Neelanjan, I also think Ellie had a question. So should we, Ellie, do you want to go ahead and ask your
Oh
question?
yeah, sorry. I was just I was reading off the.
Yeah, sure. No. I guess I had two related questions. So first, I'm wondering how what you're doing here aligns, especially when you're bringing it to the individual level, aligns with other measures that are basically ego network measures of diversity. So if for example, there's Blau's index of heterogeneity, which is often used. So obviously there you're considering essentially an adjacency matrix at best, which has me then thinking as a second question, you've been talking now about how you could play with the decay functions and the weights and things, but what else could you be doing with that distance matrix? What else could you be putting in there? And maybe not just for the data set that you have here, but how else could this be used if you had different inputs, for example, more network data or mobility data or things like that? And how, is it just a simple question then of sort of slotting that in as a different distance matrix, and then all will proceed as you've laid out for us here?
So I really like this question, partially because I think I came to, I helped with the sampling of this survey, right? And when I helped design the survey, I was very much a networks person, right? And I think a lot of you can see it in the way that I present the material, right? It's pretty clear that the critique of borders and groups is very similar to the way that somebody who's schooled in networks would critique any of these kinds of theories, right? I mean, in my perfect world, the optimal measure is essentially a network mapping right here, right? Where I'm able to give you network distance between individuals and then use, degree decay functions in order to do this. Now, I do think that it is important to go beyond the adjacency matrix, but that's done in network studies all the time, right? I mean, that's not a hard problem. So I mean, I would say that I'm not sure there's a huge difference between the way that some of the people in networks are thinking about it and the way I'm thinking about it. I would just simply say that I think that we are now in a position in social data where we can start harnessing some of that to construct the kinds of measures that we want, right? And there, as I said, there's some very basic principles. What is your decay function? What is your distance measure? What, if you're looking at variance or segregation, what is your mean absolute error? You can use mean squared error if you want, right? These are going to be tools that become, I think, increasingly helpful when we start thinking about measuring this stuff.
If I can follow up though, one thing that I was thinking is that with at least a good bit of the social data that's publicly available and whatever else, part of what you have with it to protect, to ensure privacy is basically a reimposition of borders, right? So if I was thinking to start, for example, of the Facebook mobility data that they can share in some places is one where I think they're aggregating things to census tracts. So you can look at mobility between census tracts, but to protect the privacy of the individuals, they've had to do that. So, there might be some tension here then between just generally privacy concerns with some of the data that you would want to use for this, which you basically have to have back down at the level of the individual in order to do, make the nice jump that you've done here. But that may specifically preclude some of the most interesting publicly available data, at least.
I think that's right. I mean, one of the things I was thinking about, I mean, initially I had actually written a slide on this, which is because I've been looking at the Facebook data. So in India, you can get down to 1 kilometer tiles for a lot of the Facebook data. Now, is there an argument if you are looking across a large enough space to take the centroid point and make some calculation off of that? I think we'll have to make some kind of statistical assumption, obviously, in order to do that. If I were to just quickly show you the slide here, I'll tell you sort of what I'm thinking. I mean, my usual way of giving talks is to open R, and I know this is not the optimal place. That's why I'm just going to do it on the screen this way. So you can see that the quick way of calculating this is through matrices. And this matrix D is actually just saying whether the individual is in the group or it's not. It's a binary matrix. Yeah. Oh, I put G here. Oops. Supposed to. But there's no reason why it has to be a binary matrix, right? It could be it could be the proportion of people who are from that group, right? And that could be a very simple, generalization for the multiplication, and then everything else will still work out. You'll still get a share matrix, and you'll still be able to calculate your ELF.
Okay, if we have any other questions, this is a good time. Yoni.
Unmute. Just a very geeky point, not really part of the relevant to the core of your argument. This is about index of dissimilarity, which is not what you are using. And you possibly know this point already, but I'll just mention it in a geeky way. You mentioned when you introduced it as an alternative measure of segregation that it isn't really defined for more than two groups. Now, in a certain sense, it is, because index of dissimilarity can be defined as a measure of goodness of fit for any model for any contingency table, including a independence model for two-way table, which is what this is, areas by groups independence, which is complete non-segregation. So it's defined. The only problem is that in all other cases, other than the two groups, you don't know in a closed form the maximum of it, so you can't standardize it without a tedious amount of extra work. So if somebody needed that, then it could be done as a side point, but of course that's not what you needed, and you went elsewhere, but just as a footnote, so to speak.
No, I mean, I think, so I actually didn't know the result, but it makes sense to me. I mean, I think one of the interesting things that I've sort of gotten into some of the other measures that people use is that, a lot of this was created in a time where I was like, look, I just have to come up with a measure that has certain properties. So it's almost like they're doing social choice theory, right? They have certain structures. I think one of my instinct is, as we go forward, we're going to have to start thinking about statistical principles of our measures, right? Which is why I push so hard on this sort of mean absolute error point, right? Because that I think somebody who's much smarter than me will be able to sort of take it, find faults with it, come up with another function, come up with another measure that may have better properties. But once you're working within a proper inferential framework, it's very easy to improve, right? Which is why I said this point about sort of thinking about writing down the table, thinking about it as a test of independence is actually, I think, a wonderful way of sort of characterizing what's happening in the index of dissimilarity.
Actually, can I follow that up as a more interesting question? If your experience reminded me of something. When I once wrote a paper on the index of dissimilarity for totally different purposes and didn't need to engage with the segregation literature except as a reference, I noticed from the corner of my eye reading that literature that it was amazingly bad-tempered. So there are lots of people who had very, very strong opinions about different measures of segregation and sort of dogmatic, axiomatic opinions about the properties they ought to have and why their favorite measure was obviously the only good one, and all the other measures of segregation were completely useless, if not dangerous. So have you encountered this sort of spirit in this area regarding the measures themselves?
Yeah, I mean, definitely. I mean, I think, I'm coming from political science where I think ELF is dominant. In it, as Mick mentioned, I think we use it to measure everything now. Right? I think it's not just ethnic diversity, but it is true that I think that when I look at the larger sort of, I find that, like, for instance, geographers definitely have their favorite measures and less favorite measures. I think that's group that I interact with. But I mean, I think people have broadly agreed with the larger principle that I'm working with, even if they may not want ELF as the basis for for how I'm doing it. So I have.
Yeah, just speaking up for ELF, I mean, and it's such a beautiful mathematical measure, you see. So how could it possibly be wrong? It is the probability that two people drawn at random will be from different groups. I mean, it has lovely mathematical properties. You can work with it in all sorts of ways, which most of the other ad hoc measures you can't do. It's just ugly mathematically. That's another thing.
I like it. I mean, I also like the unit square. You saw, I mean, you don't, for people who are not comfortable with the math of it, you can just show on a unit square what's going on and people get it pretty quickly. So these are the kinds of things. I see there's another question. So this is the question I was sort of thinking about, right? Which is that, if let's imagine you have very, very good census data, and you're using small precincts. So, actually there's a great paper, in some ways a motivation for some of the stuff that I've done here, by Naveen Bharti, Andali Brahman, and Deepak Malghan, who are essentially taking caste segregation estimates and looking at smaller levels of borders, and they find much higher rates of segregation than we typically estimate in India. Now, one answer there, I think you can see from this work, is that's almost mechanically going to be the case. And so I do think that it's not simply about the sample size in the geography, the size of the geography, because I mean, so let's take this to logical extreme. Let's imagine that every boundary was 4 homes. And let's think about what that kind of spatial segregation might look like. And you have enough sample size, right? So let's say that they're like high rises or something. Think a little bit about what that, what the spatial segregation measures there might look like. I think that, so it isn't just simply random sorting due to sample size that is creating deviations from a mean. There are small little differences in this part of this neighborhood and that part of this neighborhood that are making a little more white, a little more black, a little more Latino, that may sort of average out in particular ways. So I don't think that what I've shown here is a sample size effect, and probably the best proof of that is if you didn't trust the polling booths or whatever, you can actually see the exact same phenomena in the buffers, where the sample sizes are not as small. There is something about the width of a boundary that is affecting the jumpiness of the data. One way that I can kind of think about this, if you just sort of think about statistically, is that when you have larger spaces, it's almost like you're running a bigger smoother over the data than when you have smaller spaces. I mean, if you look at, for instance, the kind of census tract maps you get in the US, the Esri maps, I mean, the data look very jumpy, right? It's not just about the size of the tract. It's also something more fundamental about data properties when you have very, very small boundaries. Thank you, David.
I just want to check if there are other questions, other final questions. Give a couple of seconds, but otherwise I'd like to thank Neelanjan for joining us from a Delhi night, basically, and thank you all for coming for this last seminar for this term, and we'll be back in January then. So also have a good break, if you get a break.
Thank you, everybody. Thank you for having me. Hope to stay in touch with everybody.
Thanks very much.